Then we were supposed to find out the area of turfing. Okay, what is turfing? This is by the side of the road on the banking, some particular grass work is being applied. Okay, so what is that area? How much area we have to cover with this material or grass, a special grass or some material, so that there is no erosion. To do that, we use, okay, so what we have to do, this is the road, this is the road. So this is this portion, this turfing we are applying here on the banking. So on the sloping side we are applying this turfing. So there we have to find out what is this area. So what we are finding out, we are finding out what is this sloping length. What is this sloping length? What will be the sloping length? This is h and this is s into h. Okay, we know that already because this is the ratio. S is to 1. S is horizontal, 1 is vertical. So if vertical is 1, then horizontal is s. If vertical is h, horizontal is s into h. So we are applying this Pythagoras theorem as h squared plus h squared when we are getting up the sloping length. Then this sloping length multiplied by this length of 30 meter, we will get this area, right? So that was the formula. So this is applying Pythagoras theorem. Then we are taking out the h squared common. If the h squared comes out of the root, then it will be like this. Then that is multiplied with the length for one side, but there are two sides, so therefore it is multiplied with 2 to get the final. Now we made another table at different changes. At different changes, what is the mean height? What is the mean height? What is the mean height? This mean height we have already calculated in the previous table. So that same mean height is now we are using here. Then we are finding out the sloping rate. Okay, this value using this formula, then that is multiplied with 2 into L to get the total sloping area on both the sides. On both the sides on different changes we are finding out, and then finally we are adding them up to get the total value. Then we were also asked to find out the cost. So the rates were given. The rates were given to us. These rates will depend upon, in this particular problem, the rates were directly given. But maybe like that, we have to find out how many labors are required. We'll come to that later. But the thing is that we have to know that, okay, for this much artwork, we will need this much labor. One labor can do this much work in a single day. So that thing we have to know about later on. And then according to that, what is their wages, daily wages, what are the equipments required, is there anything to buy, is there anything to rent? According to that, we have to find out the cost also. But in this problem, it was simple. The rates were already given to us, and we just multiplied that to get the total cost. For turfing also, the rates were given. The total quantity we found out here also. We're just multiplying the rate, and we're getting the total value. And we are adding some contingencies and work source establishment. So after that, this numerical was done. Moving on to the next problem, it's exactly similar type of problem, only the difference, slight difference is there. Let's see. So here also, what we are given, different stations. These are the stations where we have done the surveying work, right? These are survey stations. So that survey station, what are the chainages? So these are the chainages from the beginning of the survey work. And then this is the RL of the ground that we have found from our survey. So those things are given to us. And at the starting point, we are given what will be the RL of the formation. What will be the RL of the formation level is given to us, and the gradient is given to us. It is same for every distance in this case. So what we do, okay, so we make one table, a different chain is, these are different chain is it, RL of the ground, we know this, sorry, RL of the ground here, we know this, okay. Now RL of formation, we have to do slight calculation here. This beginning was given to us, the gradient was given to us is 1 in 200. So that means if it is in 200 meter, it is 1 meter in vertical direction. In 40 meter, it is 1 by 5. That means 0.2 meter. With every 40 meter, we are coming down 0.2 meter in the gradient. So initial was 52 meter, then 51.8, subtracting 0.2, again subtracting 0.2, 51.6. This way we are coming down and we are finding out the RLs at different stations or different chain edges. Then we are finding out what are the differences. The formation level, the ground level, formation is 52, ground level is 51. It is higher. That means we have to fill up. We have to put some art here, do some fill up work. This is also higher. The difference, that much art we have to put higher. We have to put some water. This is also higher than 50.80. So we have to put some water. Again, we see that 51.20 is higher than 50.60. We have to give some soil here. Similarly, this one. But when we come to this one, we see that RL of the ground level is 51.20 and RL of the formation becomes 50.80. That means RL of ground level is higher now. That means we have to do some cutting, not bank or filling. So we have to do cutting. What is the difference? That much we have to cut. From here, we have to cut that much of soil. So that is the difference here. So these are the natural RL of the ground. So this is the formation level. So at some portion, we have to do some filling work, and at some other portion, we have to do some cutting work. Okay. The side slopes are given at different distances for banking, and this is for cutting. Now, we have to find out where we are having this banking and cutting. So it changes here, right? Between 1200 meter to 1240 meter, it changes from banking to cutting. So we have to find out exactly what is the point where this change occurs. So we come here, it's like this. It's like this, right? Okay, at this point, we are supposed to fill up the soil. We are supposed to banking. And here we are supposed to do the cutting. It's like this, right? This point is 1200 meter and this point is 1240 meter. So this distance is 40 meter, right? So we are using the concept of similar triangle. We are saying that this is x, okay? So x by 0.3, this height is 0.3. This is, okay? We have to do 0.3 of banking. So that height is 0.3, x by 0.3. And on this side, this is going to be 40 minus x. And this cutting that we have to do is from here is 0.4. Okay. So this is 0.3, and this is 0.4. Okay, so simple. Using the concept of similar triangle, we are getting this one. Then after that, we get this value, and we consider 14 meter for simplicity, just ignoring its very small amount in case of artwork. Within this 40 meter, from 1200 meter to 1240 meter, it is changing. The nature of the artwork is changing from banking to cutting. Okay. So we found out the values where the banking will be and where the cutting will be using the concept of similar triangle in these two portions, right? So that much is done. Now it's easy and we can put it in a table. So what we can do, we can write down different changes, right? Just like we did in the earlier one. We can write down what is the height difference at those locations, and then we can find out what is the average. Okay, so suppose at 1000 meter, this is the height difference. At 1040 meter, this is the height difference. What we consider? We consider the average one, right? We consider the average one, and then with the length to get the total volume of the artwork in that length. That is our idea. Because the gradient is changing, the cross-sectional area is also changing at every location. So therefore, what we are doing, we are finding out the mean cross-sectional area. To find out, we are taking the mean height, because height is the only thing that is changing. The breadth is not changing. The formation width is 10 meter. That is not changing. The height is changing. That is why we are finding out the average height, and then we are multiplying with the B, that is the breadth of the formation, that is 10 meter, to get the central area. What was the central area? The rectangular portion. Okay. The road is something like this. Okay, there is one rectangular portion in between, that is B into H, and this is SH square on both sides. All right. So those things. So mean height, we have one column for mean height. We have one column for the central area of the BH. We have another column for the side triangular area. We are adding them to get the total cross-sectional area at that location. This is the cross-sectional area in meters. Then we are multiplying that L with what is the distance from 1000 meter to 1040 meter. That is 40 meter to get the volume of artwork in that region. So similarly in the next, and next, we are coming. Then from 1200 meter to 1217 meter, we will have to do banking. We have to fill up. And after that, it is cutting, right? So that is the difference. So here what we are doing, we are taking the values at 1200 meter. What is the height difference? 0.3 meter. At 1217, what is the height difference? 0 meter. Why? Because it's coming like this, right? It's coming like this. So this is 1217 meters. So here height difference is 0. In this location, filling up. In this location, cutting up. So height difference is 0 at 1217. Where is my pointer? Height difference is 0 at 1217. Then what is the average? BH, the triangular portion, and then multiplied by 17 meter will give us the total volume of artwork in that location. Then we move on. 1240, we have some value at 1240. Now we have to do cutting. We are here now from 1217 to 1240. We are now here. We have to do cutting from 0 to 40 meter downward side. We have to do cutting. What is the average one? The other things are same. Now we are writing it in another column, mentioning it cutting. So this much cutting we have to do, multiplied by how much? 23. L will be 23 at this location, right? So I have not mentioned that one. Okay, so you just know, or just write it down in your note if you make one later. Then 1280, these things are again same. Now we are going 40 meter, 40 meters, so no issue. What are the age at different end? What is the average one? Now this average is from where? Please don't get confused later. This average is where? This average is from this one, and this one is this average. These two average, this one. These two average, this one. These two average, this one, right? Then the central rectangular portion, triangular portion, total cross-sectional area multiplied by length, which is 40 meter now, we get the total cutting work. So finally we add them up, banking and cutting separately. Okay, so finally we have banking work and some cutting work. So the abstract, of course, we're not finding out here in this problem, and this numerical is done.